In this lesson, we're going to look at how to find the missing sides or angles of triangles that are not right triangles. So in order to do that, we have two laws. One is the law of sines and the other is the law of cosines. So in this first example, we're going to look at law of sines. So law of sines basically is just saying that sine of the angle equals over the side equals sine of angle B over side B, and sine of angle C over side C is equal to this. So basically we can set up this proportion to solve. You can flip the proportion, you can flip each of these ratios. It doesn't make a difference, it'll give you the same answer because in order to solve a proportion, we cross multiply. So it doesn't really matter what was originally on top and bottom, as long as we remember to flip each piece. So one thing that is important here is to understand the difference between the capital letters and the lowercase letters. So when we're looking at the lowercase letters, those are going to represent the side lengths. And then the capital letters are going to represent the angles. So A, B, and C are angles. So another thing to look at here is when we say lowercase a, notice that that's the side across from angle A. Side B is across from angle B, and side C is across from angle C. So that's how we get those. So when do we use law of sines? Well, we use it whenever we want to find a missing side or an angle of a triangle that's not a right triangle. So we can't use SOHCAHTOA because that only works for right triangles. So this is we use when we want to find the side or angle of a triangle and it's not a right triangle. So we can't use SOHCAHTOA, but we need to be able to find an angle or a side, so we can use law of sines. We can also use law of cosines as well, but for right now we're going to focus on just law of sines. So law of sines you're going to use whenever you have these two cases. So basically you're given two angles and the side next to them, or you're given two angles and the side between them, and you're trying to find the other missing piece. Or if you're given two sides and an angle and you're trying to find the other angle. So for this particular case, the second one, we're not going to focus on this. This is the ambiguous case. That's a little more complicated because you can have more than one triangle possible. So this case gives you situations where you could have 0, 1, or 2 triangles. And we won't be using this, so we're not going to use this because it becomes more complicated. But it does exist, but we just won't focus on it. So looking at this first example, we have triangle ABC, so let's go ahead and draw out triangle ABC. And this little m stands for the measure of the angle. So this is going to be C. The measure of that angle is 102.3 degrees. Angle B, doesn't matter which one you call B and which one you call A. I just called C this because it was the obtuse angle. So angle B is 28.7. We know that side B, so side B, remember, is across from angle B or opposite angle B, is 27.4 feet. And we want to find the remaining sides and the remaining angles. So basically, I need to figure out capital A, or angle A. I need to figure out the side across from C, which is lowercase c. I need to figure out the side across from capital A, which is lowercase a. So in order to do this, we are going to apply the law of sines. And in order to use the law of sines, you have to have one of these cases. So if you look at what I'm given angle, angle, side. So that's why law of sines will apply. And what it'll do is law of sines will allow me to find side C right away. Because I know the two angles, B and C. I know side B, so I can figure out side C by using the law of sines. So I'm going to find C. by using the formula sine B over B equals sine C over C. So there's our proportion. So I can plug in what I know. I have angle B, so 28.7 degrees, over side B, 27.4, equals sine of C, 102.3, over side C, which is what I'm trying to find. So now what I can do is I can cross multiply this. So we get C times sine 28.7 degrees equals 27.4 times sine of 102.3. Divide both sides by sine of 28.7 to get C by itself. You do want to make sure that your calculator is in degree mode, and then you can enter this whole entire thing. When you do that, you should get 55.747, so I'm just going to round 3 decimal places, feet. So that's the length of side C, but it says to find all of the remaining sides and angles. So the next thing then, so I know that this is 55.747. The next thing I'm going to do is I'm going to go ahead and I'm going to find angle A, because if I want to find side A, I have to know the angle across from it, because in your proportion, you always have to know one of the two things. So my second step will be to find angle A. And in order to do that, you could use, the quickest way to do this is just to use the fact that you have 3 angles in a triangle that add up to 180. I can't use law of sines because I have to know either A or angle A. So that's the only way that we really can do it. So 180 minus these other 2 angles, since all 3 have to add up to 180. So that ends up giving me 49. So the measure of angle A is 49, and then once we know that, that'll allow me to use law of sines to figure out side A. So then the last piece here will be to find side A. So when I do this, I have to make sure if you're trying to find side A, you have to do sine of A over A equals, and then you can choose which one you want to use. If you want to use sine B over B, or if you want to use sine C over C. I would recommend that you use B, only because we didn't find B. It was given to us in the problem. So that way, if you made an error with C, you wouldn't carry that error. So I'm going to use B, and then I'm just going to plug in. So sine of 49 over A equals sine of B, 28.7, over side B, so 27.4, cross multiply, and then get A by itself. So divide both sides by sine of 28.7. Those cancel. We're left with A equals 43.061 feet. So I just put the whole thing in my calculator, making sure that my calculator is in degree mode since I'm entering in degrees. So then the next thing we're going to look at after this is looking at law of cosines, which again is used to find a missing side or angle of a triangle, given the fact that you have a triangle that's not a right triangle. So in order to use law of cosines, we have 2 cases. Either you're given side, 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 or you're given side, angle, side. So we have both law of sines and law of cosines because they work for different cases, different situations. So here's the formulas. Notice that these are the only things that change. So if you're trying to find side B, you have to use cosine of angle B. If you're trying to find side C, you would use cosine of angle C. And same thing with A. And then the other letters change depending on what these are. So let's go ahead and look at an example. So we have this triangle ABC. So side A is across from angle A, which is 8. So this might not be drawn to scale. And then 14 is across from angle C. Side B was across from angle B. So we want to find, when it says solve the triangle, that means you want to find all of the angles. So I'm going to, or all of the missing pieces. So in this case, I got to find all of the angles. So I'm going to go ahead and first find, I'll just start with angle B. It doesn't matter which one you start with. Remember, because this is a side, I'm given all three sides, I can apply the law of cosines to find any angles. So if I want to find angle B, that means I have to use the formula with angle B in it so that I can actually solve it. So b squared equals a squared plus c squared minus 2ac cosine of b. So then we plug in. We know that b, so let me just put the letters in here. So this is A, this is C. So B is 19, A is 8, C is 14, minus 2 times A, which is 8, times C, and then cosine of B. So my variable here is capital B, the angle B. So then what we're going to do from here is we are going to go ahead and just simplify each part. So 19 squared gives me 361, 64, plus 196. And then I would just put all this into a calculator, 2 times 8 times 14, so 224 cos of B. And then we want to combine these first. So we have 361 equals 260 minus 224 cosine of B. Make sure that you don't subtract these. You want to move left to right, so you want to do these first. And then whatever you get from these, so if it's easier to think, oh, there's a parenthesis there, whatever you get from those, then you're going to subtract off the cosine B. But since we have a variable here, we have to actually get this by itself. So I'm going to bring the 260 over. We're going to skip this example so that you can just cross off. So we have 101 equals negative, don't forget that negative out in front, cosine of B. Again, we're trying to solve for B, so we got to get that by itself. So I'm going to divide both sides by negative 224. So I end up with, I'm going to leave this as a fraction. And now to undo cosine, because we're trying to get B, we have to do the inverse. So this is where that comes into play. So you're going to take the inverse of both sides. So those cancel, and you end up with B equaling 117 degrees if we round to the nearest degree. So the measure of angle B is 117. So then that's the first one. So then we can find the next one. So let's say we find angle C next. So now that we know an angle, now I have side, angle, side, where we can use law of cosines again to figure out this other angle. Or since we have enough information, we could do law of sines, because now I know I have angle B, side B, and I want to find angle C, and I know side C. So I can go ahead and use law of sines, because that's a little bit quicker, I think. So plug in, so sine of 117 over B equals sine of c over 14. Cross multiply, so 14 times sine of 117 equals 19 times sine of c. Divide both sides by 19. So we get sine of c equals this whole thing here. And since I'm trying to solve for the angle this time, I'm going to have to do the inverse. So sine inverse of both sides of this whole thing. So the sines cancel, I'm left with c equals 41 degrees if I round to the nearest degree. And then to find the last angle, so we get 41 degrees. To find the last one, the easiest thing is to just take these and subtract them from 180. So angle A is going to be 180 minus these other two angles. You could do law of sines again, you could do law of cosines again, but the easiest thing is just going to be to take them and subtract them from 180 since they all add up to 180. So then you get 22 degrees. So keep that in mind. You just have these two formulas, law of sines, law of cosines, and depending on what you're given, if you're given law of cosines, you use side, side, side. If you have side, 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 or side, angle, side. Law of sines is whenever you have angle, angle, side, or angle, side, angle, and you're trying to find the fourth piece of information, or if you have side, side, angle. So that's the process. Keep in mind, if you wanted to use law of sines for every single problem for this, you could, but you might as well use the shortcuts when you can.